All right, we're on the last problem. And what's really nice is that they gave us a balanced chemical equation. It saves you a lot of time if you don't have to balance a chemical equation. So they told us that we're starting with, the given is 210.5 grams of calcium nitrate. And that calcium nitrate, I recognize that, and sure enough, if you look at problem number here, it was 164.1 grams per mole. So we don't have to figure that out again, although you're welcome to. And so I know that there are 164.10 grams of calcium nitrate for every mole of calcium nitrate. And now I can, my grams divide out, and I have moles of calcium nitrate. And I will do exactly the same thing here. For every 164.10 grams. Every 164 grams of calcium nitrate is an entire mole of calcium nitrate. And it says, what's the mass of each product? Well, each product is aluminum chloride. So we know that there are 2 moles of aluminum nitrate, because that's the coefficient, is there are 2 moles of aluminum nitrate for every 3 moles of calcium nitrate. And there are 3 moles of calcium chloride for every 3 moles of calcium nitrate. Now, because this is a 3-to-3, we can actually just say 1-to-1. All right, but you still have to show that step. Now we need to multiply them by the molar mass of aluminum nitrate. Aluminum nitrate, aluminum's 26.98. There's 3 nitrogens, so that's 42.03, 3 times 14. And there are 3 times 3, 9 oxygens. 9 times 16 is 144. That is 213. And I'm just gonna, just so I have room, I really need to say aluminum nitrate, but the moles divide out and I will get, let's do the math here. We have 210.5 times 2 times 213, and we're going to divide that by 164.1 and divide it by 3. Make sure you're not multiplying unless you're putting parentheses. So when I do that, I get 182.2, because I have 4 significant figures. 182.2 grams of aluminum nitrate. And I ran out of room there. Sorry. And then for the calcium chloride, the molar mass, calcium is 40.08, chlorine is 70.9, or sorry, 2 chlorines is 70.9 because it's 35.45 each. So that's 110. So I'm going to need to multiply 110.98 grams per mole of the calcium chloride. And so here we had the grams of calcium nitrate divide out, and then the moles of calcium nitrate divided out. And let's see what happens when we multiply these together. We have 210.5 grams of calcium nitrate divided by 164.1. And now I don't have to do anything here because it's times 1 divided by 1 times 110.98, and I get 142.36. Since I have 4 significant figures, I'm going to say 142.4 grams of calcium chloride. So that's how much I produce from my 210 grams, 0.5 grams of calcium nitrate. So this final question is kind of fun because we have to do everything. We have to actually, first of all, we know that we have 53.6 grams of calcium carbonate reacting with aluminum fluoride, and this sounds like it's going to be two ionic equation compounds is going to be a double replacement reaction. We want to know how much of each product is produced. So first we have to write our balanced chemical equation. Calcium we know is 2 plus, carbonate is 2 minus, and you may need to check your reference sheet. So we're going to say calcium carbonate reacts with aluminum fluoride. Aluminum, remember, is 3 plus. Since fluoride is 1 minus, I need 3 fluorides. It reacts, it's going to be a double replacement, so I'm going to get calcium fluoride. Remember, calcium is 2 plus, fluoride is 1 minus, so I'm going to have 2. I have to have 2 to make this neutral. And then the aluminum is going to go with the carbonate. Well, aluminum is 3 plus, carbonate is 2 minus, so therefore I'm going to need 2 aluminums and 3 carbonates. So the first step is to write this balanced chemical equation is actually just to write down the names of the compounds or the formulas for the compounds. So calcium carbonate, aluminum fluoride, calcium fluoride, and aluminum carbonate. Now we have to balance it. I have 1 calcium on each side, that sounds good. But here I have 1 carbonate, and here I have 3 carbonates. If I have 3 carbonates, I need 3. You can only change coefficients. Now I have 3 calciums, so I need 3 of these. I have 6 fluorides. So if 6 fluorides, I need 2 of these. Do I have 2 aluminums? Okay. So this is balanced. So step 1, balance. Now I have my 53.6 grams of calcium carbonate. All right, so to find the molar mass of calcium carbonate, I know calcium is 40.08. I've seen that a lot. Carbon is 12.01. And then I have 3 oxygens. So oxygen 3 times 16 is 48. All right, when I add those together, I get 100.09. So I'm going to just say of calcium carbonate for every mole of calcium carbonate. And since I have lots of space, I'm going to now say, let's see, we got 53.6 divided by 100.09. And I get 0.5355, and I will stop right there. That's 4 significant figures, more than enough, moles of calcium carbonate. So I'm going to make 2 problems, one where I'm going to convert this to calcium fluoride, and one, all right, so I'm going to start with 0.5355 moles of calcium carbonate, and I'm going to do my mole ratio, how many moles of calcium carbonate to the moles of calcium fluoride. So up here I have 3 moles of calcium fluoride for every 3 moles of calcium carbonate. Now I need to multiply by the molar mass of calcium fluoride. Calcium, remember, is 40.08. Fluoride is 19 exactly, so times 2 is 38. So that's 78.08 grams of calcium fluoride for every mole of calcium fluoride. I like how I have almost the whole page because I like to write big. Those divide out. The calcium fluoride divides out. I'm going to say the 3's also divide out. So I have, in fact, I can just leave this in my calculator, times that by 78.08, and I get 41.8. grams of calcium fluoride. Now to figure out how many grams of, I know that I'm going to have 0.5355 moles of calcium carbonate. I'm timesing it by my mole ratio, which is, I have 1 mole of aluminum carbonate for every 3 moles of calcium carbonate. All right, 2 times 26.98 gives me 53.96. I have 3 carbons. 3 times 12.01 gives me 36.03. And I have 9 oxygens. 9 times 16 is 96. And when I multiply all those together, I get 233.9 grams per mole. And that's for aluminum carbonate. And when I do the math here, when I take 0.5355 and I times it by 233.9 and divide that by 3, I get 41.75, or we'll round it to 3 significant figures, 41.8 grams of aluminum carbonate. There we go.